Hi guys, welcome you all to my channel Explore Edu to Teach.
So here we are with another video of EDC, that is CMOS inverter. We have already had two videos on CMOS inverter. The first being about the basic inverter, what is the kind of inverter, how does it work, the logic diagram. And the last video we discussed about the most important concept in CMOS inverter, that is the transfer characteristics of a CMOS inverter. That is at which particular input voltage value the output voltage value appears. That is for input voltage V0, input voltage VTN, input voltage VDD by 2, input voltage VDD minus mod VTP, and input voltage of VDD. What is the respective output and what is the condition of the NMOS or PMOS is very important. So knowing this diagram and knowing this transfer characteristics is very important. And that is what we learned in the last class. So in this class, we'll be solving one numerical. Okay, this was asked in the GATE examination 2007. So now I'll tell you how you should read the question, how you should analyze the diagram, and how you should map this diagram onto this particular transfer characteristics of CMOS inverter. Okay, I hope I'm very clear with this. So let's try to understand. The given CMOS inverter circuit, the parameters for NMOS and PMOS are given. So for NMOS it is Kn and for PMOS it is Kp, which is equal to 40 microamperes per volt square. The threshold voltages of NMOS is Vtn and of PMOS is Vtp, which is equal to 1 volt. Find the current. So if you see over here, you have a NMOS, you have a PMOS, you have the input voltage, and you need to find this current. So if you look at the diagram, this 5 volts basically indicates the value of VDD. The input voltage is half times your VDD. Hence, from this diagram, if you see, when the input voltage is half times of your VDD by 2, the region in which the NMOS and PMOS operates is saturation region. This is very important for you to understand. Okay, when the input voltage is equal to VDD by 2, the PMOS and the NMOS is going to operate in saturation region. That is very important. So anytime you get a diagram or you get a question in which you have this diagram given to you and you have the NMOS and PMOS over there, just try to see what is the value of V in with respect to VDD, and then you can directly determine the region in which the NMOS and PMOS operates. Okay, so what the question is saying is that you have a NMOS, you have a PMOS. They have given you the value of Kn and Kp, which is for the NMOS and PMOS transistor. They have given you the input voltage value, that is 2.5 volts. Try to find out the value of current I. Now, as I told you, since the input voltage is half times of your VDD, that is 5 volts, the NMOS and PMOS both exist in saturation region. Therefore, we can directly say, since the input is 2.5 volts, which is half times of your VDD, the NMOS and PMOS are in saturation region. Therefore, you can straight away apply the formula for the saturation region current. That is, in case of your NMOS, it is mu n Cox W by L into VGSN minus VTN the whole square by 2. Now, if you see what is mu n Cox W by L, that's already given to you over here. VGSN is equal to VG minus VS. VG is 2.5 volts. VS for NMOS is 0, right? So ground. So you have 2.5 volt. Therefore, directly put the values into the formula. IDSN is equal to 40 microampere, correct? So it is 40 into 10 raised to minus 6. VGSN is 2.5. VTN is mentioned as 1 volt upon 2, and just try to find out the value of IDSN. Now, once you know the value of IDSN, that is the NMOS, this value is same as I. right? The current in a PMOS, the current in a NMOS is equal to I, and hence you have this as the final current equation. I hope I'm very clear with this. Therefore, you have this two transistors. One is the NMOS, the other one is the PMOS, in which the input voltage is half times of your VDD. So input is 2.5 volts, the VDD is 5 volts. Therefore, I can say the input is half times of your VDD. Therefore, you can understand from the transfer characteristic diagram where is this particular PMOS and NMOS going to exist at VDD by 2, saturation region. Just apply the current equation of saturation region and get the final answer. Okay, so I hope I'm very clear with this. These diagrams and these notes will be uploaded on my Telegram group. The links are given down in the description box. You will get all these notes on my Telegram group. Also, this graph and all the short videos and the diagram pics will be uploaded on my Instagram page. The links of that is also given down in the description box. You can check out my Instagram page also and follow me over there if you like the page. So thank you so much guys. God bless.